Good morning, everybody, and happy Monday. Lesson 2-2, we're going to do today scientific notation with positive powers of 10. And then the essential question in order to engage you is how can you use scientific notation to express very large quantities? Have you guys used scientific notation before? Have you seen it in science and real world situations? Well, let's start off by watching this video, okay?
Would you believe that a tiny creature called a mite is the strongest insect in the world? Oh yeah, it can lift up to 1 in 182 thousandths times 10 to the third power times its own weight. 10 to the third power is 1,000. That mite is pretty strong, huh? So what if a person weighed 100 pounds and was as strong as that mighty mite? How much weight could that person lift? Finding out about scientific notation will help us to answer this question.
So some of you already saw that on the Are You Ready? When you some of the problems you were typing it on the calculator and it gave you this weird form. The number was already in scientific notation, but when you were trying to put in the answer, it wouldn't let you write it in scientific notation. You had to write it in standard form. So today we're going to talk about how do we switch from the scientific notation with positive powers of 10 to just standard form. Okay.
Scientific notation is a method of expressing very large and very small numbers as a product of a number greater than or equal to 1 and less than 10, and a power of 10. The weights of various sea creatures are shown in the table. How can we express the weight of the blue whale in scientific notation? First, move the decimal point in 250,000 to the left as many places as necessary to find a number that is greater than or equal to 1 and less than 10. What number did you find?
Okay, so I'm going to teach it my way. Let me see. So when you have, these are not really big numbers, but when you have really, really huge numbers, mathematicians are lazy and we don't want to write so many zeros in there. Okay. So like on this one, we don't want to write 2, 5, and 1, 2, 3, 4 zeros. So what we do is we write the coefficient. It's called the coefficient, the number in the non-zero number as a number between 1 and less than 10. So the 25, in order to make it between 1 and less than 10, we put a decimal right after the 2. Okay. So the coefficient will be 2.5 because that number has to be less than 10. Okay. So I check.
Great job! The decimal is between the 2 and 5. The 4 placeholder zeros are no longer needed and can be deleted. The next step in converting to scientific notation is to divide 250,000 by the answer you got by moving the decimal, 2 and 5/10.
So then I do it a little bit different. I'll show you right now. Okay.
This means that we can rewrite 250,000 as 2 and 5/10 times 100,000. Now, what is 100,000 written as a power of 10?
So this is the reason we're lazy mathematicians in a way, and we don't want to write so many zeros. So that's why we come up with so many shortcuts and like all these things. So I see that I put the decimal right after the 2. Well, there's 1, 2, 3, 4, 5 digits after that 2. So that's how I know that it's my exponent is going to be 10 to the 5th because there are 5 digits after I place the decimal. So that another way of looking at it is 2.5 times 100,000 gives you 250,000, and then 100,000 again. Look at 100,000. How many zeros are there? 1, 2, 3, 4. I don't want to. Okay, after the 1 there's 1, 2, 3, 4, 5 digits, so it's 10 to the 5th power. Okay.
So 250,000 can be expressed as 2 and 5/10 times 10 to the 5th power. Now it's your turn. How can you express 68,000 in scientific notation?
So
Drag the decimal point to the left to find a number that is greater than or equal to 1 and less than 10.
So in order to make it less than 10, I know that the decimal has to be right after the 6. So I put it right there. Let me see. I have to hold it, move it. And so now I know that 6.8 is less than 10. So that's going to be my coefficient. Okay, right there, the number before the times 10.
Excellent! Moving the decimal point 4 places to the left gives you a number greater than or equal to 1 and less than 10. Now divide 68,000 by 6 8/10.
So notice we moved it 10, she said 4 places to the left. 1, 2, 3, 4 places to the left. So then that means that when I divide 68,000 divided by 6.8, it's going to be 10,000. Why is 10,000? Because you have 1, 2, 3, 4 zeros, okay?
That's it. 68,000 divided by 6 8/10 is equal to 10,000. Now express 68,000 as a product.
So we multiply 6.8 times 10,000 to get 68,000. Okay.
Great job! 68,000 is 6 8/10 times 10,000. What is 10,000 written as a power of 10?
Well, remember, 10,000. It had how many digits after the 1? It had 4, so it's going to be 4 right there.
Correct. It's 10 to the 4th power. Did you notice that when you write a number in scientific notation, the exponent on the 10 is the same as the number of places you move the decimal point?
Okay, so that's the big lesson right here. When you have numbers in scientific notation, you always put the decimal right after the non-zero number. So right here, this is the 2. The decimal goes right after the 2. So there's 1, 2, 3, 4, 5 digits after the 2. So notice the exponent is 2.5 times 10 to the 5th, 5. Here you put it on the 68,000, you put it right after the 6. So it's 6.8, and then you count 1, 2, 3, 4 digits after the 6. So that's why it's times 10 to the 4th. The last one, the whale shark, it's 4.12. Oh, and by the way, you put all the numbers that are not zeros, okay? So right there is 4.12, and then I count how many numbers are after the 4? 1, 2, 3, 4 places. So that's going to be 10 to the 4th power, okay? Hope you got it. And if you don't, ask me questions.
The distance from Earth to the Sun is about 93 million miles. Express this distance in scientific notation. Click to move the location of the decimal point in 93 million to get a number that is greater than or equal to 1 and less than 10.
So once again, we're going to move it all the way to the number right after the non-zero, the 9. Right after the 9, it's going to go right there. So I drag it, and it's going to be right there.
The decimal point was moved to the left 7 places. What is the exponent on the 10 when you write 93 million in scientific notation?
So since we moved the decimal 7 places to the left, that means that the exponent is going to be 7. Another way of looking at it is, well, I moved it between the 9 and the 3. There's 1, 2, 3, 4, 5, 6, 7 digits after the 3, after the 9. So it's going to be 10 to the 7th place.
Great job! The exponent should be 7. Now express this number in scientific notation. Click to move the location of the decimal point to get a number that is greater than or equal to 1 and less than 10.
So we're going to move it. It has to go right after the 8, okay?
The decimal point moved 4 places. Now write the number in scientific notation.
So since we moved it right after the 8, it's going to be 8.4. And then times 10 to the 4th power, okay? Because there's 4 numbers after the 8. 1, 2, 3, 4.
Good job! The correct answer is 8 4/10 times 10 to the 4th power.
Any questions? Let me know.
To translate between scientific notation and standard notation, move the decimal point the number of places indicated by the exponent in the power of 10. When the exponent is positive, move the decimal point to the right and add placeholder zeros as needed. The mass of one roosting colony of monarch butterflies in Mexico was estimated at 5 times 10 to the 6th power. What is this mass written in standard notation? Using the exponent of the power of 10, how many places did the decimal move?
So instead of thinking, do I move it? What do I do? Okay. If you got 5 times 10, it's going to be 50. If you have 5 times 100, it's going to be 500. If you got 5 times 1,000, it's going to be 5,000, right? So know that 10 to the 6th power, that means it's going to be 1 and 6 zeros. So you're just going to multiply 1 and 6 zeros times 5. So it's going to be 5 and 6 zeros, right? But what we do is, okay, count the numbers after the 5. So that's going to be 6 zeros. So it's going to be 6 places. By the way, thinking about has anybody gone to see the monarch butterflies in Mexico? They are from my state, Michoacan. I haven't gone because it was too far last time, but one of these days we're going to go, okay? Anyways, 6 places.
That's right. The exponent is 6, so the decimal point moved 6 places. Place the decimal point. Since you are going to write a number greater than 5, you must move the decimal point to the right. Write the zeros that you will have to add to move the decimal 6 places.
So it's going to be 5 and then 10 to the 6th power. Remember, 10 to the 6th power is 10 times 10 times 10 times 10, 6 times. So I'm going to have 6 zeros. So 1, 2, 3, 4, 5, 6 zeros. And then the decimal is going to go at the end, right there. Let me see if I get it right.
5 times 10 to the 6th power is equal to 5 million. Now, express the number 3 and 5/10 times 10 to the 6th power in standard form.
So let me show you. If I'm confused, I'm going to go to, let me see, the scientific calculator, SBAC calculator. Oh, this is another way of checking. So let me see. Will it let me? What was it? 3.5 times 10 to the 6th power. It does give it to me right there. It's 3,500,000. Let me see. So you can always use your calculator to double check your work. Okay, so it's going to be 35,000,000. Now, how do I check? I go 1, 2, 3, 4, 5, 6 numbers after the 3, and so I have 10 to the 6th power, so then I think I got it right.
That's right. 3 and 5/10 times 10 to the 6th power is 3,500,000. If you move the decimal 6 places to the right and add zeros, you get 3,500,000.
Any questions? Use your calculator and double check, if you want to get it right.
Now let's practice with.
So on this one, it says describe how to write 9. What is it? Let me see. Ones, thousands, millions, billions. 9,134,000,000 in scientific notation. Complete the decimal. First, move the decimal. How many places? I'm going to put it right after the 9. So right after the non-digits. So that's going to be 3, 6, 9 places to the left to find. And what am I going to find? I'm going to find 9.124 because that's my number less than 10. A number that is greater than or equal to 1 and less than 10. Then you're going to multiply that number, 9.124 times 10 to the power. Well, I put the decimal right after the 9, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9 digits after the 9. So that's going to be the exponent is going to be 9. Using an exponent on 10, that equals the number of places you move the decimal. 9 places I moved it. Now I got to check it. Got it. Yay. So the next one, it says, which measurement would be least likely to be written in scientific notation? Number of stars in a galaxy or number of grains of sand on the beach, speed of a car, or population of a country? I'm going to say both the first two, the number of stars in a galaxy and number of grains of sand on the beach. Oh, but it says which one would be least likely. So the least likely would be the smallest number would be the speed of the car. So I'm going to say the speed of the car. would be the least likely to be written in scientific notation because it is likely to be less than 100 and it's considered a small number, okay? So yay, got it. Thank you so much for watching this video. Oh, from now on, I want you to put either like, didn't like, thumbs up, thumbs down, or any mistakes that you found that I make, or any suggestions that you want me to do for this one.